So I'm here today to talk about the Carlsbad desalination plant here in North San Diego County. The Carlsbad desalination plant was recently completed, December 2015. Produces 50 million gallons per day of fresh drinking water, enough water to serve about 400,000 people, or about 10% of San Diego County. I wanted to give you an overview of the San Diego County Water Authority and how San Diego is supplied with water currently. The San Diego County Water Authority has 24 member agencies and serves 3.2 million people in the region. They currently import about 80 to 90% of their water from other sources. We are at the end of a very long pipeline here in San Diego. We get our water from the State Water Project and most of our water from the Colorado River. San Diego County Water Authority is always looking to diversify their supplies, and one of the biggest ways they did that was to partner up with Poseidon Water on the Carlsbad desalination plant. You can see here the different water supplies that we have here in the county. Right now, because of conservation and demands are down, Seawater desals about 10% of the county's water supply. So the project's been under development since the year 2000. Went through a very extensive permitting process, took about 6 years. We had our local land use permits with the City of Carlsbad as well as our EIR. Then we had to obtain our MPDS permit for our discharge, our open ocean discharge. We also have a permit from the Department of Drinking Water and permits from the State Lands Commission for the lease of the jetties that go across the beach to, in order for us to be able to discharge, as well as the California Coastal Commission for our coastal development permit. The permitting was probably, the reason I included this is probably the most difficult part of the project here in Carlsbad, due to the fact that this was the first large-scale desalination plant to be permitted in California. The project was made possible through a water purchase agreement with the San Diego County Water Authority. This is a 30-year water purchase agreement between Poseidon and the Water Authority, and it transfers all the risk to Poseidon for the permitting, the design, any cost overruns, and the operations for 30 years. The way that this contract works is that Poseidon permitted, designed, and built the plant, and then they own and operate the plant for 30 years. And they supply product water that meets all water quality requirements, and the Water Authority is required to purchase that water, a minimum of 48,000 acre-feet per year, a maximum of 56,000 acre-feet per year if that water is delivered to the water quality requirements. The project and plant and pipeline cost just over $1 billion. The water breakdown is right around $2,000 per acre foot for the water from the desal plant. This here is an aerial of the Agua Hedionda Lagoon where the project is located. It is a open lagoon to the Pacific Ocean. The water travels through the lagoon from the jetties in the furthest, the bottom part of this photo. The water goes across the lagoon and into the power plant. The Encina Power Station is a natural gas power plant. We are co-located with the power plant. They use 600 million gallons per day of seawater to cool their turbines, and then we use 100 million gallons of that water after they've used it and bring that up to the desal plant. We bring 100 million gallons of seawater up the hill to the desal plant every day. We turn half of that into fresh drinking water, and the other half, with double the salt content, goes back down the hill and is blended with the rest of the seawater leaving the Encina Power Plant in our discharge pond to dilute those salts before it goes out the jetties. The Encina Power Station is in the process of being decommissioned. It will be decommissioned by the end of 2017 and will be taken down by the year 2020. They're in the process of building a modern power plant on the backside of the property, but that will be an air-cooled power plant. So when that happens, Poseidon will be building a new pump station to import their own source water. We need to import 304 million gallons per day, and that's enough water for the desalination process as well as that dilution water that I mentioned. This is an aerial of the plant just before construction was complete. This is from the south looking north. You can see we replaced an old oil storage tank that was part of the power plant, and we are just adjacent to the lagoon and the Pacific Ocean. This is an illustration of the, or a photo of the intake seawater feed line. This is a 72-inch pipeline. This is the largest pipe on site, and this brings 100 million gallons into the plant. The first stop in the process is that building behind the pipeline, and then it is our first stage pretreatment. Our first stage pretreatment is a media filter filled with sand, gravel, and anthracite. The building has 18 concrete filter bays. The seawater is filtered through these natural materials to remove any organic matter in the seawater. We do backwash these filters periodically, and we remove about a ton of organic matter every 2 to 3 days from these filters. Our secondary pretreatment is our cartridge filters. These are 20-micron filters that remove any of the other solids that the sand pretreatment have left behind. Again, we want to make sure the seawater is as clean as possible before it goes into the reverse osmosis building. These here are our cartridge filters. We do use reverse osmosis at the plant. We have 16,000 membranes in the plant. They're housed in pressure vessels, which takes 8 membranes in a row to remove the salt. These membranes are anticipated to last between 8 and 10 years. They are backwashed periodically and rotated in between the time that we switch those out. They are stacked in trains here. You can see this is a membrane train. As well as you can see the yellow devices on the bottom of the photo are our energy recovery devices that were mentioned, and I'll talk about those in a minute. This is a photo in our reverse osmosis building. We have an extra train on site so that we can always operate even when we are cleaning and rotating membranes. So one of these trains is always down while we're for maintenance. These are our energy recovery devices. We are using EIR devices, and like I mentioned, we get a 50% recovery. So for every 2 gallons we pull in, we turn 1 into fresh drinking water. The second gallon is going back out to the ocean, but that discharge is still at about 800 psi, so we're able to run that discharge through these or pressure exchangers, and we're able to recover about 46% of our energy by using these. This is a photo from the top of the product water deck. We have a 2.5 million gallon storage tank on site. This is the last stop that the water makes. We do for post-treatment, we have to add some hardness to the water because the water is extremely pure. So we run the water through our limestone reactors to add some hardness, and then we add chlorine for disinfection and fluoride to fluorinate the water to state standards here in this product water tank. And then these are our 8 product pump delivery pumps that pump the water 10 miles inland. The water climbs about 1,000 feet in elevation to the aqueduct where the water is delivered. This is the pipeline. The pipeline, like I said, went 10 miles inland. Poseidon also constructed this pipeline, and when the pipeline was complete, turned it over to the San Diego County Water Authority. The pipeline went through 3 cities, Carlsbad, Vista, and San Marcos, and it connects with the Water Authority's aqueduct where the water is delivered to all of the agencies in San Diego County. It is a large portion of the treated water supply coming into the county. The pipeline is a 54-inch concrete and steel pipeline. You can see the photo here, the scale of the pipeline. This is the last piece going in the ground. That's it for my formal presentation, and I look forward to questions at the end.